Are you ready to peer into the future of computation? Imagine a world where today's most complex problems, from drug discovery to climate modeling, are solved in mere moments. This isn't science fiction. It's the promise of quantum computing, a revolutionary field poised to redefine what's possible. Join us as we demystify this cutting-edge technology, exploring its fundamental principles, incredible potential, and the exciting journey ahead. At the heart of all computing lies information. In classical computers, this information is stored as bits, which can represent either a 0 or a 1. Think of a light switch. It's either on or off. This binary system forms the foundation of every digital device we use today, from your smartphone to supercomputers. Quantum computers, however, operate on a fundamentally different principle, leveraging the bizarre rules of quantum mechanics. Instead of bits, they use quantum bits, or qubits. A qubit isn't just a 0 or a 1, it can be both simultaneously, thanks to a phenomenon called superposition. Superposition is like a spinning coin in midair before it lands. It's neither heads nor tails until you observe it. A qubit exists in a combination of 0 and 1 states at the same time, allowing it to store exponentially more information than a classical bit. This ability to hold multiple states simultaneously is a game changer for processing power. Beyond superposition, quantum mechanics offers another mind-bending property: entanglement. When two or more qubits become entangled, they are intrinsically linked, regardless of the distance between them. Measuring the state of one entangled qubit instantly reveals the state of its partner, even if they are light years apart. This interconnectedness allows quantum computers to perform complex calculations by processing multiple variables simultaneously, leading to an immense computational advantage. Building a quantum computer is an extraordinary engineering challenge, requiring extreme precision and control over individual atoms or subatomic particles. Unlike classical processors that rely on silicon chips, quantum computers often operate at temperatures colder than deep space to maintain the delicate quantum states of their qubits. These specialized environments prevent decoherence, where qubits lose their quantum properties due to interaction with their surroundings. Various technologies are being explored to create stable qubits. Superconducting qubits, for instance, use superconducting circuits cooled to near absolute zero, allowing electrons to flow without resistance and exhibit quantum behavior. Trapped ion qubits suspend individual ions using electromagnetic fields, manipulating their quantum states with lasers. Each approach has its unique advantages and challenges, pushing the boundaries of physics and engineering. The true power of quantum computing lies in its ability to tackle problems currently intractable for even the most powerful classical supercomputers. One of the most exciting applications is in drug discovery and materials science. Simulating molecular interactions at a quantum level could revolutionize the development of new medicines, design novel materials with unprecedented properties, and accelerate the search for sustainable energy solutions. In the realm of finance, quantum algorithms could optimize complex portfolios, detect fraud with greater accuracy, and model market fluctuations more precisely. For artificial intelligence, quantum machine learning promises to enhance pattern recognition, accelerate data analysis, and enable more sophisticated AI models. Quantum computers also pose a significant threat to current encryption methods, driving the development of post-quantum cryptography to secure our digital future. Despite its immense promise, quantum computing faces significant challenges. Building and maintaining stable qubits is incredibly difficult. They are highly susceptible to environmental noise, leading to errors. Error correction is a critical area of research, as current quantum computers are prone to errors that can quickly corrupt calculations. Developing robust error correction techniques is essential for building fault-tolerant quantum computers. Another hurdle is the development of quantum algorithms. Unlike classical programming, writing code for quantum computers requires a deep understanding of quantum mechanics and specialized programming languages. The talent pool for quantum programmers is still small, but growing rapidly. Furthermore, the sheer cost and infrastructure required to build and operate these machines mean that quantum computing will likely remain a cloud-based service for the foreseeable future, accessible through specialized platforms. The future of quantum computing is a dynamic and rapidly evolving landscape. We are currently in the noisy intermediate-scale quantum (NISQ) era, where quantum computers are powerful enough to perform calculations beyond classical capabilities. but are still prone to errors. The next major milestone is achieving quantum supremacy, or quantum advantage, for practical real-world problems, demonstrating a clear and undeniable benefit over classical methods. As the technology matures, we can anticipate the development of more stable and scalable quantum hardware, alongside increasingly sophisticated quantum algorithms. Quantum cloud computing platforms will continue to expand, democratizing access to this powerful technology for researchers, businesses, and students worldwide. The ethical implications of quantum computing, particularly concerning cryptography and AI, will also become increasingly important topics of discussion, requiring careful consideration and proactive solutions. The quantum revolution is not just a distant dream. It's unfolding right before our eyes. Understanding its principles and potential is crucial for anyone looking to stay at the forefront of technological innovation. Dive deeper into this fascinating field. Explore the resources available, and consider how quantum computing might shape your future. What are your thoughts on the incredible potential of quantum computing? Are you excited about the breakthroughs it promises, or do you have concerns about its implications? Share your insights in the comments below. Don't forget to like this video, subscribe to our channel for more cutting-edge tech insights, and hit the notification bell so you don't miss our next deep dive into the future of technology.